Hello students, welcome to the series of Physics and Mathematics brought to you by e-eklavya.com. You can also reach us at our YouTube channel e-eklavya learning. In this chapter we'll study about vectors and scalars. So the topics which we are going to cover are basic definition of vectors and scalars, and then we'll look into some of the vector arithmetic, and we'll also look into resolution of vectors, addition, subtraction, multiplication. Multiplication will be going through multiplication by scalars, vector dot product and vector cross product. So let's get into the definition of vectors and scalars. Any physical quantity which can be classified as either vector quantity or a scalar quantity. So what's a vector quantity? So any physical quantity which can be completely described by magnitude and direction is called vectors. So the two words are specific here, magnitude and direction. So some of the examples are velocity, force, any kind of force field, right? So let us understand this concept in a little more detail. So when we say velocity, what we mean is the speed combined with the direction of the object. That is called velocity. Speed in itself is a scalar quantity. And so let's see what's a scalar quantity. Any quantity which can be completely described only by magnitude are called scalars. So if you have to say mass of a body, right, or let's say speed of an object or distance traveled, for example, you say the car traveled a distance of 10 kilometers, right? So the physical quantity that we are describing here is distance. So 10 completely describes the physical quantity distance. Okay, so that is a scalar because we can completely describe that physical quantity distance by only its magnitude. We don't need the sense of direction here, right? On the other hand, when we say that a car is moving with a velocity of 10 kilometers per hour in east direction, so here in order to specify the velocity we need to give the speed at which it is traveling and the direction in which it is traveling. So an object traveling with the same speed in opposite direction are having two different velocities. So now this concept, here you need to clearly understand that vector is something which needs both magnitude and direction. So consider this, any kind of force, right? Gravitational force. So when we say gravitational force, we need to specify. So gravitational force is generally towards the center of the earth, right? You take an object and raise it to a height and leave it, it falls down on the earth. So that force has a direction, right? So if you say gravitational force of a certain magnitude, so that is completely described by its magnitude and direction together. Similarly, in your later chapters you will come across electric field, magnetic field and some other kind of force fields. So all these force fields need a sense of direction. Without that, they cannot be completely described. Okay, now here we have a small animation. So another vector quantity is called displacement, which is when we say an object is displaced from one position to the other, we mean the net distance it traveled, right? So here the car is moving in east direction with a speed of, let's say, 10 kilometers per hour. So the velocity is described as 10 kilometers per hour in east direction. That is the velocity, but speed is here 10 kilometers per hour. Okay, now in the bottom animation, what just happened was, if we take the distance of the red arrow as 2d, so actually the car went to the other end and came back. Okay, so it actually moved a distance of 2d into 2, right? So 2d is the distance which the car moved. Now, but if you see the displacement, the car came back to its original position, so the displacement is 0. So displacement is a vector quantity, whereas distance moved or distance traveled is a scalar quantity. So this is a small example of similar kind of physical quantities, but so displacement is vector, whereas distance moved is scalar quantity. Okay, so I'll take you forward. So consider this here in the general physics. So this chapter is physics and mathematics. So vectors are used in many places when you go forward. So you will understand many formulas are derived by these basic concepts. So what I would ask you is, go through these concepts again and again and make sure you understand them very clearly, because these are going to be very useful when we discuss other topics. So these things have to be crystal clear. Okay, now here what we are talking about is resolution of vectors. Now what do you mean by resolution of vectors? Resolution of vectors, a vector is denoted by generally a vector is denoted by an arrow. So if you see here, a vector A is denoted by symbol A with the arrow on top. So this is how we write vector quantity. So this arrow is the notifies that it's a vector quantity. Okay, now let me, so here what we're trying to do is we're trying to break this vector in two components. Now why would you want to break a vector in two components? Now this would be useful when we are trying to deal with multiple vectors. For example, we're trying to deal with two forces pulling an object. So you need to understand where would be the resultant force. Okay, so in order to solve these kind of problems, we would need to resolve vectors. So when we resolve vectors in two different axis, x-axis and y-axis, so here you need to understand that x-axis and y-axis are just two reference axes. Okay, that does not mean that you cannot have your own defined axis. Okay, so if you understand the basics, it would be very easy for you to go forward. Okay, now for the general purpose, we generally take it as x-axis and y-axis. So x-axis is the horizontal one and the y-axis is an axis perpendicular to it, right? Okay, so the vector component along x-axis will have a magnitude of a cos theta. What is cos theta? Cos theta is cosine of an angle theta which the vector makes with the x-axis. Okay, here basics of trigonometry would be very helpful. Okay, now here how do we get this the magnitude along x direction as a cos theta? That we can get it simply by the basic formula of trigonometry: perpendicular and base. Okay, their ratio gives cos theta, right? So, and I is a unit vector along x-axis. Okay, so I gives a sense of direction to this magnitude a cos theta. Okay, similarly along y-axis the magnitude is a sin theta, and the unit vector along y-axis is j. So if we have to resolve vector a along x-axis and y-axis, we can write it equivalently as a cos theta plus a sin theta, and I and j would give the direction. Okay, so now if we have another vector called b which makes an angle alpha with x-axis, we can resolve it in a similar fashion. And we can, so if we want to find the sum of two vectors, so what we can do is we can add the individual components. For x-axis we can add, and for y-axis we can add the magnitude part. Okay, so I hope you are getting a sense of why we are trying to resolve the vectors along two axes. Okay, and you can only resolve a vector once. That does not mean that if you have a vector along x-axis, you should further resolve it along y-axis or something like that. So what I am trying to say here is that you need to understand that if a vector is making an angle theta with a particular axis, so along the axis is the magnitude of the vector multiplied by the cosine of the angle. Okay, and perpendicular to the axis is magnitude of the vector multiplied by sine of the angle. That is the two components. Okay, so let us move forward. And as I was saying earlier about addition of vectors, so now we will learn about another rule of vector addition, which is called triangle rule of vector addition. So if you have seen in our earlier example, we represent vectors geometrically, and that gives us easy visualization. Okay, so the triangle rule of vector addition is basically a rule which defines how two vectors can be added and what would be the resultant. Okay, so we have here we have one vector a and the other vector b. Okay, and the resultant is c. So in order to find the value of c, we need the magnitude for C, and the direction. Okay, so let me get this thing. What just happened was the parallel translation of vector B. Okay, I moved vector B from in parallel direction. Now, does that change anything? Now, in order to explain that it does not change anything, the vector B after the parallel translation is still vector B, I'll give you an example here. So, in a first slide, remember we talked about velocity. Velocity is something which is speed and direction. Now, consider two trains moving in parallel tracks, both moving at, let's say, 100 kilometers per hour and moving in, let's say, southeast direction, both the trains. Okay, so although both the trains are moving parallel to each other, but they have the same velocity. How can we say that? The speed is same and the direction in which they are moving is same, right? So the velocity for both the trains is same. Okay, so what does this mean? This means that if you translate the vector, if there is a parallel movement of vector along this, so the vector remains unchanged. Okay, so similarly we'll move vector A. Now the reason we are extending these geometrical shapes is for our convenience, so that we can arrive at a formula of addition of two vectors. Okay, now so we talked about resolution of vectors along two axes. Now we will see how we can add the two vectors A and vector B. Okay, now here let us get few things clear. So alpha is the angle which vector the resultant makes with vector A or the horizontal x-axis. So vector A is along the x-axis. Okay, so the curious question here is, what is the component of vector A along y-axis? So component of vector A along y-axis is A sine theta. Now what is the angle vector A makes with x-axis? 0 degree. So what is the component along y-axis? A into sine of 0, which is 0. So there is no component of vector A along y-axis. Okay, so so these two vectors A and B, we are trying to add them. So this vector here and this is, we are trying to add these two. Okay, now so the angle beta is what vector A makes with vector B. Okay, so this is our vector B. So it makes an angle beta with vector A. So all our computations will be in terms of angle beta, right? Now if you see geometrically, so this here is 90 degree. Okay, and so here we'll use simple Pythagoras theorem. So what we have here is AD square, that is the hypotenuse square, is equal to AE square plus DE square, sum of the other two sides, square of this, sum of squares of the other two sides, right? That's the Pythagoras theorem. Now In fact, the actual definition of Pythagoras theorem is a bit different from what I just said. We'll deal with Pythagoras theorem later, but historically that's not the actual definition. Okay, but it translates into the same thing, right? So AE can be broken down as AB plus BE. So what is AB? AB is vector A, magnitude part, okay, and BE is what? BE is resolution of vector B along x-axis, okay, which is B cos beta. And why beta? Because beta is the angle which vector B makes with x-axis, and since vector A is parallel to x-axis or along the x-axis, vector B makes the same angle with vector A, okay, right? So the other part, DE, is the resolution of vector B along y-axis, which is B sine beta. So the simple math, you expand the squares and you get the resultant formula. I will leave it up to you to do the simple computation. This is nothing so great, very simple, okay. And so what we have got is the magnitude part, okay, and what we need now is the direction, okay. So direction here we will define by the angle, okay. So the angle of the resultant with respect to x-axis, alpha, that is given by this small formula, tan alpha equal to dE by AE, okay. Similarly, you replace you break AE as AB plus BE and substitute the values, so you get the formula B sine beta by A plus B cos beta, okay. Now the angle alpha is definitely the tan inverse of this quantity, right? So for subtraction is similar to addition, only thing is, if you can see here, A minus B can be written as A plus minus B. And what is minus B? Minus B is nothing, same, the direction is opposite, okay. Fine. So let us talk about vector dot product and vector cross product, okay. So what is a vector dot product and vector cross product? This is basically two different types of multiplication of two vectors, okay. One leads to a vector as the resultant, the other leads to a scalar as the resultant. Now when we use either of them, that we will discuss when we will be dealing with separate vector quantities, and we will see why we are using either of them. Here we will only try to discuss about the concept of vector dot product and vector cross product, okay. So dot product is also called the scalar product, and cross product is also a vector product, okay. So, and it is written by A dot B, so that is how we write dot product of two vectors A and vector B, okay. So the magnitude is given by AB cos theta. And some of the properties of dot product is commutative and distributive, okay. So A dot B equal to B dot A, similarly A dot B plus C equal to A dot B plus A dot C, that is distributive property. Okay, so and physically it may not be very clear to you right now, but the dot product of A and B is the length of projection of A onto B multiplied by the length of B, or the other way around. Now, what is the length of projection of B on A is B cos theta. Sorry, A cos theta. Length of projection of A onto B is A cos theta, and you multiply it by B. So, or it either way, length of projection of B multiplied by the magnitude of A. That is the vector. That is the scalar product called the vector dot product. Okay. Now I would want you to just understand this concept as of now. We will deal with this in little more clarity with examples in the later chapters. Okay. The cross product of two vectors A and B, represented by A cross B, so, and the magnitude. So you see, this is these two vertical lines. So enclosing any quantity between these two vertical lines indicates that we are trying to say what is the magnitude of this, the quantity enclosed inside. Okay, that's a notation. That is AB sine theta. Okay, so magnitude is AB sine theta. Now since the cross product of two vectors is another vector, so we will need the direction also. So the direction of the resultant vector is given by the right hand thumb rule. So as the figure, as you can see, if vector A is along one finger and vector B is along the other one, so if you hold them as shown in the figure, so the direction of the resultant is towards the thumb, which is clearly shown here. So that is also called right hand thumb rule. Okay, this gives you the direction of vector. Okay, now the other concept, very quickly I'll go through. It's zero vector. Zero vector is nothing but a vector which has got zero magnitude and a particular direction. Okay, so for example, if you add if you subtract two vectors of equal magnitude, the resultant is a zero vector. It has a mathematical significance. Okay, so that marks the end of the concept of vectors and scalar. Thanks for watching. Go through the other videos. Okay, thank you.